Hello everyone. I am Pagi Rushikesh Balasai, roll number 25. So our group member is Siddharth Shendikar, Dhiraj Sagar and Sahil Rani. So our presentation topic is analysis of current and voltage ripple in DC to DC converter. So first one is the index. So first is the introduction, overview, methodology, simulation, block diagram, simulation result, advantages, disadvantages, application, conclusion and reference. So introduction. So first is a ripple. Small fluctuation in DC voltage and current caused by switching action in DC to DC converter. So what is DC to DC converter? DC to DC converter is a choke point. Affect efficiency and performance of the system. Too much ripple hitting EMI load issue. Control using inductor, capacitor and filter. So filter is unwanted DC signal and capacitor to store the electric charge and inductor to the delay of electric current. So overview of this presentation is first is a ripple. Small fluctuation in voltage and current in DC to DC converter. Voltage ripple occurs across the output capacitor. Current ripple occurs in the inductor and load. Excessive ripple reduce efficiency and cause EMI or heating. Proper design and filter help minimizing ripple effect. So second is presented by Sahil Rani. In the methodology, we analyze the current voltage in ripple DC to DC converter. First, we select the converter type and define the operating parameters. Means we define the operating range of parameters, the model and circuit of inductors, capacitors, switches. Then we calculate a voltage and ripple current within a standard formulas. Various standard formulas for the using the current and finding the ripple currents. Where in the simulation and experimental setup, we are finding the actual simulation waveform graphs and optimize the components value. The switching frequency we are taking the 50 Hz to minimize the ripple current and ensure stable operation. Advantages in the advantages ensure that the stable and reliable converter operations helps to improve efficiency, reduce the power losses. Means that it's DC to DC converter is used to improve efficiency and reduce the losses, minimize heating in electromagnetic interface, protect the sensitive electronics load from damage, guides proper selection of inductors. Means in the setup we use the proper inductors capacitor with this parameters range for give the proper efficiency. Next slide is presented by Dhiraj Sisal.
Advantages. First is ensure stable and reliable converter operation. Second, disadvantages. First, causes power losses and reduce overall efficiency. Second, generates heat in components affecting their lifespan. Produce electromagnetic interference EMI in the nearby circuit. Can disturb sensitive electronic loads and device. Required additional filter and components, increasing cost and complexity. Application. First, power supply. Ensure stable voltage for electronics device and circuits. Second, renewable energy system used in a solar and wind energy convert for smooth DC output. Third, electric vehicle. Maintain stable voltage and current for motor and battery systems. Fourth, telecommunication system. Reduce noise and improve reliability of communication equipment. Fifth, consumer electronics. Protect sensitive devices like laptops, smartphones, and LED drives.
My name is Shendikar Siddharth. I am presenting conclusion. Conclusion. Current and voltage ripple in DC to DC converter are unavoidable due to switching operations, but analyzing them is essential for efficient and reliable system performance. Exclusive ripple can cause power losses, heating, electromagnetic induction, and damage to the sensitive loads. By properly selecting inductors, capacitors, and other devices, implementing filters, ripple can be minimized, ensuring stable voltage and current. So, ripple analysis is therefore critical in designing converters using power suppliers, renewable energy systems like solar, wind, electric vehicles, and electronic device to achieve optimal efficiency and performance. Okay, thank you.
everyone, my name is Chandrakar Siddharth, and today we are representing the DC to DC ripple converter in MATLAB Simulink. First of all, go to the MATLAB online or offline. There is a login to log in your account and go to the simulation. Then go to the new block. Take a new block. First of all, we have do the simulation to necessary the MOSFET, so diode, inductor or capacitor or there is a resistive load or pulse generator to generate the pulse and give to the input as a MOSFET. Here is a DC source, here is the voltage source, and here is the scope. To scope is the to visualize the waveform. So DC source positive connected to the MOSFET terminal. MOSFET terminal connected to the diode terminal. So diode is connected in parallel, and here is the inductance for improve delay the current, and here is the capacitor to improve the efficiency, and here are connected resistive loads. So here is a voltmeter connected across the resistive load. So we have observed the waveform. Here is a double click to scope. So here is the output waveform. Here is output. So here is I think around 14 straight inch, and there is a power guy block. There is necessary to run the simulation. There is a discrete power GUI block. So here is the run symbol. We can simply click, your simulation will be run. Your stop time we have used 10.0. So here is the waveform. See. Okay, thank you. Thank you.